So if you're playing with R Cloud, you're going to have that file available inside your project. So if you're running inside of R, you can just run that from where you downloaded it, or you can take it out of your downloads file and put it somewhere else in a folder, which is probably a good idea because we downloaded the stuff. So down here in the lower right-hand corner, you'll see there's a little upload button. And you can click on that. And then it will say, where do I want to have it come in? Well, I want to have it come into my project. And then choose file. And at that point, you can say, hey, here's a little program file that I want to upload, and it will upload it for you. And when you've done that, you can then see down here, the file is available for you to use. And in order to then say, hey, that's the thing I want to run, you double click on it, and you'll see that it appears up here in your program. Yes, thank you.
Okay, so I was kind of confused on how to do this whole thing.
This hasn't been assigned yet. Yeah.
Okay, I was just messing around with it because you told us that we needed to, and I'm confused on like for a long time the 4 sections of the screen wasn't showing up on my project.
Oh, that's weird. What did show up?
It was just blank.
Well, do you get this little panel down here in the lower right-hand corner?
I can start a new.
Now fire it up. You can look at it. I mean, that's also kind of a good thing in terms of office hours. You can just script some. We should, at least the other people who have done our scores, I'm not sure. Sometimes if you're not connected to the internet at the time, maybe it's only coming up with nothing because it's thinking or it's trying to. Everything that's being done here is being done. With a little like
It worked now, so maybe it was just being really slow.
yeah. So what I want to draw your attention to is these little blue things called library. Inside of R, all of the packages and software are not readily available. You have to tell R, hey, I want to access this and that program. And if you're doing this inside of R Cloud, and we're not doing anything fancy at the class level to make sure the libraries are always available, every time you click on this for the first time of your session, it's going to say, oh, I don't have this library, I don't have these programs to come and use yet. If you're playing with R on your computer, once you've installed it, it's there, and it will always be there. But what I've done here in this little example is there's a little bit of a package that will give me some data to work with. And there's another package that will let me do correlations and a confidence interval. And there's another package down here that will let me do a plot that's fun to look at. So at this point, we just need to know, hey, library access packages. If you want, upstairs underneath tools, you can come out and install packages and type in the name, for example. And that will install. In R Cloud, it takes a little bit of time to install, so I'm not going to do it now. Yeah. If you are in R and you try to run this package without installing it, it'll give you a little message saying, hey, I don't have that program. Should I install it? And you can click yes, and it will install for you. So to tell the program, hey, I want to, right, the other thing I want to talk about is at the very top, you'll notice there's a line in green with the pound sign. That's a comment line. So anytime you want to make a note to yourself as to what this is doing or what this is supposed to be doing, pound signs will work for comments. So as long as you start things with a pound sign, it's going to green out the rest of that. So in order to run the line, you just put your cursor on that line and then just run button. And you say, hey, I'm loading a whole bunch of packages. And the reason I loaded this one is it has the data set that represented the very first time somebody did regression. It was Galton's study of the inheritance of height. So, I'll up that set. We'll say data and Galton. How would I know to do that? Well, here, I'm just going to give you stuff to run. So you don't need to worry about the whys and wherefores of it. Later on, we'll figure out how to get into the packages and get into the documentation. We won't do that right now. So I've called up the data set. It's available for me to analyze. And now I might want to take a peek at it. So view Galton gives me this. It opened up a new tab for me. That shows me that I've got two variables, child height and complete parent height. I've got a whole bunch of observations. I can scroll down and look at them. Notice over here in the right-hand column, kind of like Joe mentioned in the video last time, I've got an environment variable there that says, hey, you have a data set that you're analyzing. It's got 928 observations and it's got two variables in it. So this is, stuff you can play with or stuff you can peek at and look at if you want. Well, that view is fine. I'm not moving this, so I'm not out of that. Maybe I want to look at summary statistics for that. Well, summary is going to give that to me. It's going to give me the percentage points and some ideas about the distribution. Down here, it shows me the lowest score, the highest score, the median, the mode, the 25th percentile, the 75th percentile for the child variable and the parent variable. Now, maybe you've all done sort of that collective flush of anything statistics now that you're done with it, but do these terms make sense to you now? Are they still with you? Maybe I want to do a simple plot. Well, here's where a little bit of R's strategy comes in. I want to plot some data. The Y variable is a function of the X variable, and that little tilde is just an equal sign. So when you see that, that's equivalent to saying Y is equal to the X plus a constant, the regression I want to solve. And this $sign notation says go into the data set Galton and look at the variable child. Because inside this data are kind of hierarchical. Over here in the data statement, I can click on that. And I can see that inside the data set Galton, there's a variable called child, there's a variable called parent. These are not numeric, they're not character variables. And here's a peek at the first few observations. So if I want to make a plot, since hit the run button. And lo and behold, the plot appears down here in the lower right-hand corner. If I don't like seeing that teeny tiny, I can hit the zoom button and it will give me a big picture of it. It's a little bit ugly. It doesn't look like there's 980 people here. And the reason that's a little bit ugly is Galton, way back when, only kept his numbers to a certain degree of precision. So at each of these data points, there might be lots and lots of people. In spite of that, I can say that, yeah, there's probably a positive association going on. If I want to save this, well, you could screenshot it. The other thing you can do is right click on this and save the image down here. And here is a PNG file. Another thing you can do is I can save this as a PDF. that. We'll say, hey, this is going to be a PDF. How big is it supposed to be? You can change these to be, it's going to be 8 wide and 5 tall. It fits portrait landscape. And that file can then be written to your cloud project you can have. So you, for example, say, oh, let's just call this. It is. Not terribly nice, but I could change the sizes of the PDF. So you can get your stuff out. So if you're writing a paper next semester and you got a picture and you want to put it inside your Word document, maybe you just want to take that PNG file and save it. Everyone's quiet. Breaking things down to teeny tiny parts. Well, suppose I want to do my scatter plot, but I really kind of like to know how many people are around here. So, in other words, I want to take every observation and kind of move that dot around so I can see if there's 5 people or 10 people inside. That's a process known as jittering. So if I want to do the same plot again, I want to say, now I want to jitter these points and look at that plot. Here's what things look like that. Well, now you can see that those points that were down there are kind of more or less the same. There's not many people here, and there are a lot of people here in the middle. And you can kind of see that there's a linear relationship going on between these two. So we're looking at Galton's data here. And the reason we call regression is Galton wrote his paper and was worried that the English were regressing to mediocrity, that parents who were very short tended to have children who were taller than they were, like 64, 64, people over here. And similarly, parents that were very tall, 72, tended to have children who were shorter than they. He thought in his first speeches that he gave that this was some new phenomenon that was afflicting the English. And later on, he realized this is an artifact of that thing called regression to the mean, that because these variables are measured with error, the people you observe down here maybe don't truly belong down here, maybe they belong over there, but because of measurement error, we have this phenomenon of extremes observations being related to other observations that are closer to the mean. Well, maybe we want to look at what is that correlation between these two variables. Calculate a correlation, so we say core, and then name our two variables. And it appears down here, here's a correlation. Well, maybe I would like to do confidence intervals, because the book talks about confidence intervals quite a bit. This 0.46 doesn't give us an idea of the statistical validity of that point estimate. If a point estimate is just a single number you get out of your values. The confidence interval represents a range of plausible values. Well, to do that, I need to go into the psychometric library. And maybe I want to peek at my data a little bit. I can do that with this string function. And that gives me kind of the same information as you saw over here. This would be the first few observations of the variables on. And to get the confidence interval, I say, I want a confidence interval on the correlation. I want to have these two variables be the correlation. The sample size that I have is the number of rows in this data set. And the alpha for this confidence interval is 0.95. So if I want to have the 95% confidence interval, I need to input the correlation and my sample size corresponding to that. So and that, we now get the following confidence interval. Apologies, I just turned my phone off. And that represents the 95% confidence interval. So you copy these things out and paste them into the article you're writing or the project paper you're writing.
I think I missed it. What's the number 5 in the? What is that?
This one, that determines the amount of jitter. You didn't miss it, I forgot to explain it. So say, for example, I don't want to have as much jittering or dancing around those points. Maybe I can change that to the number 1. And then I can hit the run button again. And my numbers don't dance around quite so much. Generally speaking, and this is, sort of decimal dust comments, but maybe what I really want to do is to jitter the children and not jitter the parents at all, very little. Because that's going to kind of give me an idea. I'm not moving the parents around very much, but it gives me an idea. I don't want to really jitter a lot because that's going to distort the functional relationship between the variables.
Like the more the data sets are, the closer they are to that.
Yep. The smaller the jitter, the closer they are to their true value. You can put in any old number there. Okay, well, these plots are kind of nice, but sometimes you want to make a plot that's going to look really, really pretty. And the package that people use for plotting things that allows you to make things really, really pretty is called ggplot2. Who's at Penn State really loves this. And I have to kind of say it's kind of the default outside of psychology at the moment. So we call up ggplot2. There we go. I need to say, hey, here's the library. And then here's a bunch of stuff. Big picture, what I'm wanting to do here is I'm using the ggplot program, and I'll get into these things in a minute. But instead of printing it out right away, I want to take that plot and write it to an object that's going to appear up here. And the reason I want to do that is when you're making a plot, maybe you have 5 or 6, it becomes frustrating if you have to twiddle this and twiddle that and do things to it. So the way that you work often with ggplot is you make a simple plot and you save it, and then you add the twiddles onto it to make it beautimous later. So in this case, I'm making a first plot object, and I'm calling the data set. And I want to use X as the predictor and Y as the criterion. And I want there to be plots here. And I can override this point by putting in separate things in it. And I want to take a look at the regression line, the least squares. And I want to take a look at the standard errors. So if we just run this for the moment, no output got produced. But what happened up here is that object got written out there. We can sort of look at it. It's a little bit ugly. Stuff going on there that I don't really care about. At this point, if we come in though, and we say first plot, and just hit and just look at it, here's what our diagram looks like so far. It's big. So I didn't jitter anything, but I'm showing you the regression line, and I'm showing you the standard error. So for objects that are close to the mean of parent and the mean of child, the standard error is very small. And the further that we get away from the mean of parent, mean of child, the wider this standard error becomes. So if I'm looking at making predictions of people, I don't have as much confidence. If I had a smaller sample, this would be more dramatic. I don't have as much confidence in my prediction value as I would if there were things at the mean. This is again, this phenomenon of regression to the mean acting out its nightly waves on you. Because down here, I'm predicting from a lower level, I don't have as much accuracy in my estimations of y as I do here. Fun fact, every regression line always goes through the mean of x, mean of y. So if you're reading an article and you're being skeptical, and the person reports the means of their variables, and they report the regression line, if you plug in the mean of x, you better get the mean of y out. If you don't, they made a mistake, either an analysis mistake, or they forgot to tell you something like patterns of missing data that exist. So as before, I don't like this because it would jitter. So downstairs, if I want to make my plot, I can say, hey, do that first plot, but now do the jittering. And I can then run that file. At which point, I've now got my jitters. So, how do you feel? No. There's always two, what's that Disney thing? Like this little angel on one shoulder and a devil on the other. It's like, oh my God, they're bored. Is this kind of on target? It's just walking you through the code. And again, your first assignment will be, I send you something, you run it, you send me back a PDF or something. Right. So another, as an example, another data set that we can do is something called the Anscombe data set. And to access that data, data Anscombe. And you'll notice inside of my here, view Anscombe, and I've got a little data set here. Well, some of this visually kind of stinks in terms of size, but for those of you in the back of the room, we've got x1, x2, x3, x4, y1, y2, y3, y4, and we have some numbers down here. Precisely 11 observations. And this data set was published in the American Statistician as a caution to statisticians who just said, I'm going to run a regression, I'm going to run my program, I'm done. It speaks to the value of doing some exploration of the data. So let's make a plot of that first data set. So just as before, ggplot, I'm going to use the Anscombe data set. I'm going to use the first predictor and the first criterion on that, and I want to look at some plots, and I want to look at the straight line. So if we're looking at that, on it, and behold, this looks nice, doesn't it? There is, generally speaking, a nice positive relationship. This is what we saw in the Excel example. Yeah. Just as we did in Excel, I want to do a regression. I'm going to call up the linear models program, LM, and say my criterion is a function of the predictor, and here's the data set to use, please. And that gives me the regression equation. Well, I can call that, and that just gives me that material. I can take that same thing and I can put it into an object inside of R. And the reason that I want to do that is there's more stuff inside of there than just the printer, than just that equation. So it's giving me the coefficients that I have. It also gives me the residuals. It also gives me the predicted values. It also gives me some other things on diagnostics that we don't need to talk about right now. But the things that are of interest is, hey, I've got the regression coefficients, 3 and 0.5 that I just saw down here. I've got the residuals. What are the residuals? So the residuals are the observed value minus the predicted value. So it's kind of nice to have for a data set you're analyzing some idea of what the residuals are, because if you're looking at it, go, oh, wait a minute. As I mentioned last time, for some of these lines, there's just one outlying observation that's way the hell and gone. And really the prediction of everybody else would be perfect if I just didn't have that person. I can use, if I want, sometimes it's kind of not terribly nice to have those coefficients out to 100 decimal points. I can print out the numbers that I have inside my first model and the coefficients to 3 decimal points. And when I do that, I'm going to see my numbers. I'll see my numbers rounded to 3 decimal points as opposed to all the decimal points that it has happened. Round is kind of nice for a lot of things. Sometimes when you're analyzing, especially large data sets, it's going to come out in scientific notation. So you get something like 1.5674 e to the point of 802. It's just not a convenient number to read. And Round will put these numbers out for you in the format that is possible. And as we mentioned before, here's the second. These are the same things that we saw in Excel. Similarly, hey, the regression. So that's an intro to running a file, doing some regressions, and working with this. Here's a bunch of environmental variables. Here's my program. The output comes out here, and my graphs come out here. I'm going to put a pin in that. This is a lot of material. And what I'd like to do for the rest of our time is to do a little bit of review for the test. And what we'll do is use some of the items that are in the test bank. I'm going to stop the recording here at this point. I can't put that up on YouTube.